I'm going to take a look at problem number 26 from section 4.8. This is the implicit differentiation section. You can see a hyperbolic graph here, x squared minus y squared equals 36. And this is a pretty basic example of a hyperbola problem. I'm going to change the problem just slightly. I'm going to find the slope of the tangent to the graph at the point where x is equal to 10. And so I'm going to transfer over here to my paper. You can see my equation here. And specifically, the first thing I'm going to do is differentiate implicitly. The important thing here to keep in mind is this equation is not solved for y. Okay, this is an implicitly defined function, not in y equals form. Yes, I could solve for y in the equation. When I take the square root, I'd get a positive and a negative value and have to take two different derivatives. However, much easier to do implicit differentiation here. So remember how this works. If I'm trying to find dy dx, I want to take the derivative with respect to x of these variables. Okay, so my derivative here is going to be derivative of x squared, if I follow the power rule, is 2x times the derivative of the inside function with respect to x, and that's going to be dx dx. Yes, that's equal to 1, but I think it never hurts to leave that in there. Derivative of y squared with respect to x is going to be 2y times the derivative of the inside function, which is dy dx. So that is the derivative of y with respect to x. And that does not cancel out to 1. And be careful here. The derivative of a constant is just equal to 0, and that seems to be something that people miss pretty often. Dx dx is the same thing as 1. 2x times 1, of course, is just 2x. So I have 2x minus 2y times dy dx equals 0. And in this case, I like to isolate the dy dx. So I'm going to subtract 2x from both sides of the equation. End up with negative 2y times dy dx equaling negative 2x. Now I can divide both sides by negative 2y, and I find out that dy dx is equal to just x over y after I do my cancellation. Right, to finish this out, I want to find the slope of the tangent where x is equal to 10. Notice here, unlike the book problem, it doesn't actually give me the other coordinate of the point. So I'm going to go back in here and I'm going to substitute in a 10 for x. That gives me 100 minus y squared equals 36. I can do various things here. I can subtract 100 from both sides. I'm going to find out in this case that negative y squared is equal to negative 64, meaning that y squared is equal to 64. And this is where you have to be careful. I'm taking a square root of both sides. Remember that there's a positive and a negative square root. So y is equal to either plus or minus 8. So I actually have 2 points here. I'm going to be substituting in 10 for x. I'm going to be substituting positive or negative 8 for my y value. Okay, and if you take a look over here, here's y. When x is equal to 10 on the graph, notice that I have a point up here and I have a point down there. I'm going to have two different tangent lines. And so I can substitute back into the original equation. Obviously, when x is equal to 10 and y is equal to 8, I get a dy dx value of 4/3. That's the slope of my tangent. When x is equal to 10 and y is equal to negative 8, I get a derivative of negative 4/3. And it never hurts to take a look back at your graph and see, does that make sense? And if you take a look back at the original graph over here, you can see the slope of the tangent at 10 looks like it'd be a little bit bigger than 1. 4/3 makes sense. Down here, looks like it'd be a little bit less than negative 1. Okay, again, negative 4/3 makes sense. So those are my final derivatives at those points using implicit differentiation.